Okay, we're going to talk about equations in one variable. An equation in one variable is a statement that contains two equal expressions. A property of equality for all real number A, B, and C. A is equal to A. We just need to get ourselves familiar with these terms and definitions. Reflexive property. Symmetric property means if A is equal to B, B is equal to A. Transitive property. A is equal to B. If A is equal to B and B is equal to C, then A is equal to C. So if you take a look at this example, 3x plus 5 is equal to 25, or 4 over 7 minus A is equal to 8. These are just examples of equations. Solving linear equation, it should be reviewed for most of you at this point. A linear equation in one variable is an equation written in the form ax plus b is equal to c, where a, b, and c are real numbers and a cannot be equal to 0. Why a cannot be equal to 0, anyone? Those of you following this live with me. Why a cannot be equal to 0? Yeah, because a is equal to 0, then we don't have any variable x there, right? The x could be gone. All right, so we have 3x plus 5 is equal to 25 minus 5x. Take a look at this example. This is an example of linear equation. Linear means we don't have any square anywhere. We don't have x to the power of 2 or x to the power of 3. The power of a variable x is 1. That's what we call a linear equation. Any value of a variable that results in the true statement is called the solution. So if you can pick a number that make this a true statement, that would be the solution. That's what we're working on. So we should be able to determine whether a number is a solution to an equation. And that's really simple. That's all we have to do, is just substitute that number into an equation and see if it works or not. And we should do that actually at the end of solving any equation, see if that is actually indeed a solution. So in this case, if I substitute for each x negative 1, and check that out, looks like that is a true solution. So 12 is a solution for that equation. So we're going to learn how to solve these equations. Addition and multiplication property of equality. We're going to use these two properties to really solve equations. Here the first one says if A is equal to B, then you're allowed to add any number to both sides of the equation. The second one, if A is equal to B, you're allowed to multiply any number to both sides of the equation. We do that to isolate the variable and solve for it. So we have x plus 6 is equal to 11. First example. We are allowed to add any number to both sides of the equation. What number are you going to add to both sides of this equation to isolate x? You're going to add negative 6, right? In other words, you subtract 6 from both sides, basically. It looks like you're adding negative 6 to both sides of the equation. So basically, you subtract 6 from both sides of the equation to isolate x. So x is equal to 5. Another way to look at it is sometimes you've seen some books, they say you move this 6 to the other side of the equation. Have you heard of that before? When you move a term from one side of the equation to the other side, its sign changes to its opposite sign. So if I have, this is another way to look at it. If x plus 6 is equal to 11, I want to isolate x. If I move this to the other side, its sign is positive, it will become negative. Really what we're doing is we're subtracting 6 from both sides of the equation. So as you can see, it would be x equal to 5. Example 4, multiplying number to both sides of the equation, like 3y is equal to 12. What do you multiply to both sides of this equation to isolate y? You multiply both sides by, not 3. If I multiply both sides by 3, it becomes 9. 1/3. Reciprocal of that coefficient. You multiply by reciprocal. The reciprocal of 3 is what? 3 is 3 over 1, right? Reciprocal of that is 1/3. Okay? So if you have a coefficient being a fraction like 2/3, to eliminate that, you multiply by its reciprocal, 3/2. Any number times its reciprocal would be equal to 1. So here, I know in past you heard that you divide both sides by 3. That's another way to look at it. But you really multiplying both sides by 1/3. So y is equal to 4. So this example here, 3a minus 9 is equal to minus 24. We have to do both. We have to add 9 to both sides of the equation and then divide both sides by 3. then you get a is equal to minus 15 over 3, so a is equal to negative 5. So let's take a look at how to solve this. For those of you watching this later at home, now is a good time to pause the session and see if you can get the same answer. Here we have 3a minus a is equal to 2a minus 15. All right. I have a choice to move all the a to the left or all the a to the right. Better to move the smaller variable where the larger variable is located. Later when we work with inequality, then we don't get a negative coefficient. So in this case, I would have 3a is equal to 2a minus 7. What we're doing here is we're adding 8 to both sides of the equation. I'm going to move 8 to the right. If I add 8 to both sides of the equation, then I get 15 plus 8. That would give me negative 7. So now I need to isolate this by subtracting 2a from both sides of the equation. 3a minus 2 is equal to a, so a is equal to minus 7. We can always check our answer by substituting for each a negative 7 to solve for, to see if you have the right answer. Distributive property, we use that to simplify expressions. If we have a times b plus c is equal to ab plus ac. Let's say we have 3 times x plus 5. We use the distributive property to distribute that. You get 3x. 3, we distribute 3. 3 times x would be 3x. 3 times 5 would be 15. Obviously, this is not equal to 18x. These are not like terms. 3x plus 15, they are not like terms. Just leave them as is. Another example. Here we're going to distribute the 3. Become 3x plus 3y plus 2y, and then we combine like terms. So the 3x, we can combine the y's, 3 plus 2, that give me 5y. Solve the equation using distributive property. Once again, if you're watching this later at home, it's a good time to pause the session so you can get the same answer. See the first one. We're going to distribute the 3, negative 3 here. Negative 3 times x will be negative 3x. Negative 3 times 2 give me minus 6. And then here I can combine like terms on the right-hand side. So on the left-hand side also I can combine like terms. I got negative 2x minus 3x give me negative 5x. 12 minus 6 give me 6. On the right-hand side, so that everything's combined. So here I can subtract 3x from both sides and subtract 6 from both sides. If I subtract 6 from both sides of the equation, I get 12 minus 6, which is equal to 6. Here it looks like we are moving the larger x where the smaller x is located. That's why we get this negative coefficient. But you should get the same answer. Divide both sides by negative 8. That gives me negative 6 over 8. Which always has to be reduced. In this case, it would be negative 3/4. Next example here. I can subtract 9 from both sides of the equation. Get 2x equal to 14 minus 9 is equal to 5. Divide both sides by 2, x equal to 5 over 2. This is a very simple example of solving equations. Next one, 5 minus 2a over 3 is equal to minus 9. Here I can multiply each term by LCD, by 3. So if I look at this as being 5 over 1 and minus 9 over 1, the LCD is 3. If I multiply each term by LCD, you would eliminate all the fractions. That's one way to do this. If I do that, I get 3 times 5 would be equal to 15. 3 times minus 2 over 3 would be equal to 2a. Don't forget, each term should get multiplied by 3. 3 times negative 1 would be negative 27. So these two equations are equivalent. This equation here and this equation here. By multiplying term by LCD, you make the equation look simpler to solve. So here I can isolate a by subtracting 15 from both sides of the equation. subtract 15 from both sides. I get a negative 27 minus 2 is negative 42. Then divide each term, both sides, by negative 2. That's the coefficient of A. Then it would be equal to plus 21.
These examples were from the first presentation for the PowerPoint for Chapter 2, where you can find it in the multimedia library. Please continue with the rest of the examples, and as usual, post all your questions in the discussion forum.